Hello, this is John from ke12programming.com. In this tutorial, we're going to start looking at pointers in C++. This is a language feature that that you don't find in too many other computer languages, and it sort of baffles beginners, but we're going to take it slowly here. We're going to start looking at pointers in this tutorial, and we're going to move on in subsequent tutorials and look at more stuff that you can do with pointers. So let's declare an int here. I'm going to say int, I'll just call it n value, the n just standing for integer, and I'll assign it a value, let's say 8. So here you can think of this as being like a bucket that we've put a value into. It's we've allocated some memory, and the amount of memory we've allocated is controlled by the fact that we've got an int here. And of course we can change that. We can set the value to something else and so on, and we can output it. Let's try that. And let's say int value and n value. Oops, need a put to operator there. Let's just check that this works. So yes, I want to save it, and now it says int value 9. Now you can actually create a variable that stores the address of this int rather than the value itself. So to do that, I can type int, and I'm going to type an asterisk here, like that. So we read this as int pointer, or pointer to an int. Int pointer is kind of trips off the tongue faster. And because this is a pointer, I'm going to prefix it with a p. You don't have to do this, but it just helps make it clearer that it is a pointer. Let's say p. I could put n for int as well if I want. This is just stuff just to help me remember what it is. So pn value. Now I can set that to point to the address of this int by typing equals and a ampersand, which you can read as address, and n value. So I'm saying here pointer to an int equals the address of n value. So what's actually stored in here is not an int, it's not this value, it's the address, the memory address of this bit of memory here, this int, and we can output that as well. Let's do that. Let's say here pointer to int address, let's say address. Now let's output this pn value here. So if we copy that, paste it in there, save this and run it, then we get a memory address in hexadecimal. So this is just a number, the OX just says it's hexadecimal, as we saw in a previous tutorial. This is a number in hex, and this is the memory location of that int there. So what can we actually do with this? Well, these are very useful in C++. They have a lot of different uses, but one thing we can do is get back the original int. So let's paste in another cout here, like this, and say int value via pointer. Now, if we just put the actual pointer variable name in here, of course we're going to get the address again. What we can do is something called dereferencing the pointer, and to do that we just type an asterisk in front of it, and this gives us the value that the pointer refers to. So let's try this, and when it runs we get 8. So we've got several bits of notation, syntax here. Here we're using a star, we're saying int star, or like another way to write it, which maybe is nicer, but depends on your preferences really, is to put the asterisk directly before the variable. That also works. So we're using the star here this is the type of this variable. So the type of this variable is, we read it from right to left. The type of this variable is pointer to an int. And then we use the ampersand here to get the address of a value, in this case an integer value. And then here, if we want to output the value that the pointer points to, the actual value at the memory address, which is contained in the pointer, we use an asterisk just before it to dereference it. So this gets us the actual value that the pointer points to. It gets us the value stored in the memory address, and we've stored that memory address in the pointer. It's the easiest way to understand this is just to practice using it, because I find you can read explanations of this, and it's really hard to remember which asterisk and which ampersand goes where. It's only when you use it and you type it out that you really start to get a feel for it. Let's look at one thing in this tutorial that you can do with this that's sometimes quite useful. Let's declare a function up here. So I'm going to say void, and we'll call it, let's call it, I really don't know actually. I'll call it manipulate. And let's make that take an int, so int value. And what manipulate will do is we'll just say value equals 10, like that. And let's do a cout, value of int in manipulate. And let's output that value there, endler. So I'll output here, let's output some just text just to separate this stuff out a bit. And then I'm going to declare, let's have another int in here. Let's say, in fact, let's maybe use a double just to demonstrate this with something else. Let's say double value, and then we can say value is 10.0 and value of double in manipulate. So I'll declare a value here, a double. Let's say d value, that'll do. Set it equal to 123.4, and then let's output this value. So let's say d value, I'll put a 1 before this, 1, d value, and we'll output the double value there. Then let's call manipulate, and pass it that double value, d value, like that. And then let's output that again, and say d value again. So we're declaring this double here, and we're setting the value of it. We're outputting that value, so we expect to see 123.4. We're calling manipulate, we're passing this double in, and that actually sets the value to something else, and it outputs what that something else is. And then we're outputting the double value back in the main function again after manipulate. And if we run this now, we're going to get in main, so the double value starts off at 123.4. In manipulate, we change it to 10 and then output it. So maybe we can make this actually a little bit clearer by putting another cout in here. Let's say here 2, 3, and then I'll make this 4. Let's run this. So when we run manipulate, to start with the value is 123.4. In manipulate, we pass that value in, it comes in here, and we output it. So again, at 2, it's 123.4. Then we change it in manipulate to 10, and we output it again, and then it's 10. And when we output it after manipulate in the main function, it's 123.4. The reason for that is when you pass a value like this into a function, it's like pouring data from one bucket to another. We're actually copying this, we're copying the value in this double here, copying it into this value, and in this function we're changing this value. We're not changing this, we're just changing something that happens to contain a copy of that value. So this here is a new double, and when we call manipulate and pass that value in, we're just taking this value putting it into this copy and changing the copy so that when we get back into the main function, when after this manipulate returns, our original double still has its original value. The fact that we changed a copy of it here doesn't make any difference to it. Now usually that's what you want, and it makes things simpler to have functions behave like this, but sometimes you want a function to be able to literally change a value. And there's another way of doing this in C++ called reference variables, which we'll look at. But one thing you can do is to use a pointer. Let's change manipulate so that instead of taking a double value, it takes a pointer to a double. So I'm going to type here an asterisk. So now the type that we pass in here is pointer to a double. And if we compile that, it's not going to compile because now we have to pass in not the value itself, but the address of the value, because pointers contain addresses of values, literally memory addresses where those values are stored. So we need to type here an ampersand to get the address of this. So now we're passing that in, and now we don't want to assign it a value 10 because this will contain the address of this. If we assign it a value 10, we're saying, okay, change this memory address to 10, which is pointing at some random bit of memory. We don't want that. Here we want dereference value, so I'm going to put an asterisk there, and that says change. This says change the value that this pointer points at. So actually go to that bit of memory and change it. Now I think we can try running that. Let's try running this. So now we see that I've got value of doubling manipulate, we've got the memory address. Let's change this to dereference the pointer as well. I should have probably called it p-value really, just to emphasize that it's a pointer. I think that'll make it a little bit clearer. Let's do that. And now let's save it and run it. So now what's happening is we get the double, we output its value, so 123.4, we pass the address of it to manipulate. That stores it in a pointer variable. It stores the address of our original double in this pointer variable. We output it, we output not the address but the value at that address, which is 123.4. We change it to 10.0 by dereferencing the pointer and changing whatever value is stored at that memory address. We output it again, we output the dereference pointer, so the value at that address, and of course it's 10 now. And then back in the main function, we output the double value, and now it has changed because we actually went to the address and changed the value. So in this version of the program now, there's only one double. We don't have a copy of this double. What this is the address of the double. There's only one double, and this pointer points to that double. It has the address of that double, and we can use it to change the original value stored at that address. So that's it for this tutorial, and I'd highly recommend that you practice this yourself. So just do what I've done here. First, try typing out a value, whatever you like. Could maybe try an int or a double. That's probably simplest. And then try declaring a pointer to that value, and like this, and try using the pointer to change the value. So of course we could change the value here using the pointer as well. We could say star pn value equals some int, like that. Try doing that sort of thing, dereferencing the pointer, and then declare a function that takes a pointer as its parameter, and try passing the address of one of your values in your function to that function. Try changing it in the function and see what you get afterwards. So try to do all this, and try to do as much from memory as possible, but you're almost certainly going to have to refer back to this to remember it, but try to look at it as little as possible and see how far you can get. You'll probably find, if this is new to you, that you'll make a lot of mistakes in getting this to work. You'll probably, it's not too difficult to actually do this bit, but you probably need to refer to this a few times before you can do it from memory. And then this bit, when you actually pass a value to a function and that function actually changes the value by using a pointer, that's a bit tricky as well, and you'll probably make some mistakes first time you do it. But it's very, very good if you can get to the point where you can type out this code and you can create functions that take pointers and change the value of the variable using that pointer by dereferencing it from memory. Because once you've done that, you've really got not such a bad feeling for pointers, I think. So that's all we're going to do in this tutorial, and we'll look at pointers more in the next tutorial. But yeah, it's good to practice this, because we're going to do more stuff with pointers in subsequent tutorials, and it's going to get more complicated, but not much more. So don't worry. And once you've understood this, you can really kind of give yourself a pat on the back, because this is something that defeats a lot of beginners. A lot of people know C++ to a point, but pointers is the point at which they sort of give up. So it's really worth persisting with this. And I'd say don't agonize about it too much. The thing is to get your fingers to kind of remember it, remember what you have to type where in order to get this to work. And then the understanding sort of tends to come later on. So until next time, happy coding.